Hi, and welcome to our webinar today, Integrating Predictive Analytics and Interactive Data Visualization. Thanks for joining us. I must say that we've had incredible response to this webinar, really our best response ever. So we're really excited about showing you what we have to talk about today. Without further ado, let me introduce our speaker for today, who is Doug Cogswell, President and CEO of Advisor Solutions. He has spent many years, over 15, in the business intelligence and computer software sector, and has extensive data analytics experience along with strategic consulting background with a BA in physics from Dartmouth and an MBA from Harvard. He combines those unique strengths to be really an expert in the field. In addition, he is highly regarded as a thought leader by Gartner, Forrester, and most of the industry analysts. So welcome, Doug.
Well, thanks, Kim. I'm excited about this webinar, and it's a build on a TDWI report that we sponsored, which came out a month ago, about data visualization, and it brought out some themes of the importance of integrating data visualization with predictive analytics. So that's what we're going to talk about today. And after a brief setup, we're going to go into a couple of examples. I think these are examples that are going to be specific to certain problems, but they're going to be generally applicable. The first one's on finding target segments, high performers, low performance. And the second one is a topic a lot of people have asked us about, is time series, where multiple factors influence performance over time. We'll run through how visual discovery can help you untangle what's going on, but then predictive analytics can really help validate the hypotheses and assumptions you see from the visualizations and make it really come alive. So from the TDWI report titled Data Visualization and Discovery for Better Business Decisions, you can actually get the full report from our website, so I would encourage you to do that. It's a well-written report and highlights some of the overall trends and themes and directions in this rapidly growing sector. But you know, the concept here is data visualization is the confluence of science and practice, and human powers, the human mind is designed to perceive things visually. So one of the things that's making visualization so powerful is taking business data and using color and shape and spatial layout to highlight things and help people see stories with the mind perceiving them the way it's built versus typical tabular reports and summary stats. And you know, the mind responds to stimuli, and there's also been a lot of public discourse, which has also helped this come really alive in the recent couple years. And expectations are rising for visual excellence in BI and analytics overall. There's tons of reports, and there's this one, the TDWI report gets into that, but it's critical to making smarter decisions. And the report highlights that the cost of poor visualization, users can be misled by the daily onslaughts of data they're getting, and there's increasing velocities of data. There's more and more sources. We'll see in a minute some of the social media stuff that's just there. And integrating this and seeing it and making sense of it requires much better visualization than ever in the past. It's also essential towards this whole self-directed analysis and BI that's getting a lot of press and visibility, because business people can respond and interact with things they see visually much, much better than they can with machine language and SQL code and all the old concepts that you have to, in the past, have used to cut data, slice data, and form it in the ways that you need to make business decisions. It's a hot trend. The report highlights a high percentage of respondents both using visual discovery and analysis today and also looking to, and it's across functional areas, and it needs to integrate with apps, and there's new tools that are fueling this, so the technology has also helped enable this trend and push it forward. And I really like this page. It encourages storytelling and new forms of collaboration, using visualization to narrate and provide context to the data story being told. We have accounts that will use interactive visualization in board and management meetings. So they'll have a discussion up on the screen around some data, and people are seeing things and they're asking questions about outliers or why something's red. And on the fly, the person leading the discussion can interact with the charts, and the data changes and answers come, and the storyline comes out to the board and the management, and they get insight and understanding that's just not possible with traditional tabular reports, and the need to go back to requery, recut them, and come back a week later, well, the board of directors has finished its meeting, they're not there, and they forgot what the question was. So this is just, I love this concept of highlighting what's actionable for colleagues in a meeting and all this storytelling. I think that's a really good capturing of what it does. So let's take a look at one. Here we have, we're going to go through an example with some mutual funds data, but this is going to be a story about segments and outliers, and we're going to look at a few concepts: spatial layout, color, shape, and we're going to combine graphic, stats, and lists. So I think a good visualization does all of that. So let's take a look. I'm going to I'll open up a browser and bring up a visualization of some mutual fund data, and we'll walk through it. So it comes up. There's some text on the right that describes what we're looking at, but basically it's about 1,800 mutual funds. We've invested $1 billion. 3-year average performance is 15% plus or minus, and it's got some volatility. So there's some stats, and then it's a bar chart which starts highlighting some things because they fall into some categories, and it's showing how much is invested in each. So here's a chart that pretty quickly shows by far away the biggest one is the growth category with $343 million invested, and the smallest is the Treasury, the fairly standard chart. The one on the right is taking those funds and showing some more information about them. So from a visual discovery perspective, this is taking low 3-year performance to good 3-year performance, bad, good, and volatility, less volatile, more volatile. And this chart shows a few things. It shows that there's this sort of efficient frontier where there's a relationship among these funds between volatility and performance. Higher performance, higher volatility, lower performance, lower volatility. But there's some outliers. There's a group up here that are doing really bad, and there's a group up here that are kind of doing much better. And by the use of color, for example, the blue up here, you can sort of see where the patterns fall. So we've coded these things so everything blue is in the balanced category. So when you look at this, you quickly see, hey, the balanced group has this pretty tight performance along this efficient frontier. There's another group up here. By the way, when I'm mousing over them, I'm getting brush-ups that are telling me what I'm looking at. So I'm highlighting a specific fund there. But I can sort of see this has a different pattern. Let's click it. The small cap, I select it. I'm seeing my selection compared to the whole. This has a fairly tight band of performance, but a wide range of volatility. If I want to look at the balanced, they're much tighter. So I can quickly see by just a couple of charts like this and the use of color and this interaction, I can start untangling that. Yes, I do have 1,800 funds that fall into some categories, and there's different behavior characteristics of those different categories. And down at the bottom, I've got a list. So, for example, here's a really bad fund. If I put the mouse on it, the brush-up comes up. It points in the growth category, and the bar chart shows me what it is. And the line of the data sheet at the bottom, which is all the funds, it brings up the stats for that one fund. It's the Stedman Tech. It's a growth fund. It's had bad performance, bad 3-year performance, bad return. So all the stats come up for it. So that's the concept here. You're using spatial layout and coloring and to understand a portfolio. Now, it's one question you might have with this is like, what is the characteristics of this whole segment that's in this top left corner? So I can select that. So let's grab down to these guys. I can grab the top left corner, which is 142 funds, and I might want to get an idea of what are these. Well, the coloring over here shows me I can quickly see in the bar chart. It's got more coloring than the others, so I'm showing that group compared to everything else. Well, 22% of my international funds are in that top left quadrant, and the biggest group I have of the top left quadrant is international. It's like balance is pretty much in the clear. So I'm starting to get an understanding as I explore the data. I'm getting a feeling that if I want to look at this top left corner, which concerns me, it's got some skew towards fund category. Let's look at another view of this. Same selection. The pie chart tells that story pretty well, too. I can quickly see that the concentration of that top left corner, which is what's colored and everything else is gray, I'm seeing the selection compared to the whole is heavily international. And here's some stats, 121 of the funds. So I've gone from one view, another view, which is helping color it in. A heat map view is going to show me something different. So it's going to show a portfolio, and it's going to show by size and layout and color what I'm looking at. So let's actually bring all the data back for a second on this heat map. I'm going to reselect everything. What I've done here is I've taken my whole portfolio, and this is the growth category, and it's sized by the investment in it. And then this is one of the funds. The top left is the Fidel and Magellan fund. It's my biggest because it's the biggest square, and it's colored by the average 3-year performance, with bad being red and green being really good. So this is pretty good. So at this level, I can look at my portfolio and say, hey, yeah, overall my growth category is doing pretty well. My international's got some wide variance. It's got like a really good fund here, this one, and it's got some really bad ones over here. My small cap is more balanced. My mortgage and treasuries are more median overall. Now that selection, that top left corner, which I was looking at before, let's go back to it, is now I'm showing where those groups are compared to the whole, and I quickly see the concentration. It's heavily international. It's not my biggest, but it's some of my mid-range ones. A couple of scattered small funds everywhere else I probably don't care as much about. So it's another view of that. This is the idea of visualization to help you understand what's going on in a portfolio. Let's look at another view. This is a more statistical view of that same data. So here we have what's called a parabox, and we've looked at the fund categories, and colored is what's selected. I've got 26-week performance, 1-year performance, 3-year performance, 5-year performance, 10-year performance. This is performance over greater periods of time. My invested position, a beta, which is another volatility measure, the volatility measure, expense ratio, and manager tenure. So there's other metrics in this data which I'm trying to understand. Well, what I selected was the poor performing 3-year performers. So this is this box plot. This line in the middle is the median of all the funds. The colored ones down here are what I selected, which are the low 3-year performers. And I selected high volatility. So you can see on this is the median of all the volatility. Well, I've got a whole group up here that's high. So I see the 3-year performers did pretty bad, obviously, because I selected them. Some of them did better by the 5- and 10-year point. A couple of them did really well at the 26-week and 1 year. So here's the real outlier. This one did best 1-year performer, got really bad 3-year. Let's look at it. So I can go up here and select, intersect this one fund, and I can see its pattern. The capital appreciation did really well at the beginning, then it crashed. I've got a low invested position, reasonable beta, high volatility, long management tenure. Let's look at this one back on the first page. So here it is. I might want to examine this one. It's colored right up here. It's a little outside of the area I selected. So what I'm doing here is I'm using visualization. Let's go back and reselect my group to try to untangle what the pattern is of those funds that are in that top left quadrant that worry me. And there's another one, some histograms, where I'm seeing my selection in a distribution of 3-year performance and net assets and so forth. So that's the concept of visual discovery. And what we just did there was we used spatial layout, color, shape, combination, graphic, stats, and lists to get an understanding of a database population. So it shows data in context. I was able to select, observe, exclude, restore, identify characteristics. And actually, one thing I meant to show you, which I'm tracking all of the steps I was taking, and it's basically a cookie crumbs trail is being recorded of every step I did, so I can go back and repeat it, show it to somebody else, know exactly where I was in context. We'll come back and see that in a minute. So taking predictive analytics, we're going to take the same problem in a minute and run a model against it to see what else we would learn. It uses mathematics and tools and algorithms to examine patterns in one set of data. For example, in this case, it might be those low return, high volatility, top left quadrant, in order to predict behavior in another set of data, which other fund members might be expected to have that kind of behavior, and it integrates well with in-memory data visualization. The concept here is you select a target. We selected a target. That top left quadrant was a target we selected visually. The base population is the rest of the funds. There's a bunch of explanatory fields that are in the core table. We saw some of them in the charts. They can also be calculated and joined from other tables. We'll see an example of that in a minute. We're going to run some regression algorithms, and whenever we do this, the algorithms are going to show mathematical correlation. The human mind needs to interpret this and make sure that they're actual causal, that they actually are logically likely to cause the behavior versus they're just coincidentally related. We can hit more on that in a minute. So let's take that same example. I'm going to drop into a client version where I have my predictive modeling tools. So here we've got this top left quadrant selected. We want to run a predictive model and see what more we can learn. So I'm going to go down here, build predictive models, a panel, You could do this, this are modeling tools, but there's a lot of ways of modeling tools where you could do this. This is the bad performers, my model I'm going to build. And I've only got one table in here. The next example will have quite a few tables. This is a type of a model where you're not targeting in a field. This is not something you're forecasting return on or you're forecasting revenue on. You're actually doing what's called a classification model, which is this currently selected group compared to the rest of it. So in modeling, there's some things that you can mathematically forecast. There's others that are more set membership like this, or if we do a lot of work in fundraising, you can forecast potential giving, but you can't forecast the number for propensity to come to a reunion or attend an event. That's a set membership. So we offer two kinds of models. This we have to use the set membership classification model. Here's all the explanatory fields. These are variables that were in that table. I obviously need to take off 3-year performance because it's one of the things I selected. If I didn't take it off, the model would tell me that's highly relevant to my selection, which is not particularly meaningful. Let's take off 5-year, and we can argue whether these others, the earlier returns ought to come on or off. Let's leave them on for now. I need to take off volatility. And for now, let's leave everything else in. So I got a couple of net asset measures. Let's take one of them off. So the modeling algorithms are robust. If there's overlap in the fields, it'll figure that out and properly handle it. What we're trying to do here is take some really rich regression-based algorithms and package them in a way that somebody who knows the data well, has a mind for the data, can operate this and get insights. So I click OK. And it's running 20 to 25 models behind the scenes. It tells me that I've got a good R-squared. It believes the information adequately explained the target, which is this group up here. And it believes that if it's given more information, it can predict pretty well. It tells me that 26-week performance is the biggest contributor to understanding a 3-year poor performance with volatility. And over here is the buckets it created. Let's slide this a little bit. Yeah, really bad 26-week performance is more likely to be bad. These are the ones most aligned, and these are the ones least aligned. So that's probably not a surprise that the poorer early on performance is more likely to relate to worse later on performance, although we did see at least one noted exception to that. Fund type came in next. Equity is most aligned to having that poor performance. A balanced bond and is less. There's some other things. So looking at this, let's do a quick edit. Get out the 26-week performance because it's aligned with the selection. Maybe get off the year-to-date performance. I'm going to edit the model. So typically how you would do something like this is an iterative process. Take off 26-week performance. Let's take off year-to-date performance, which is down here. Let's take off return since inception, since it's basically the same measure. And let's take off, what else should we take off? Return since inception, 1-year performance. So we're just going to drop those things out because we looked at them. We know there's some outliers, but generally they're co-aligned with the behavior that we selected, the same basic identifying measure. Click OK. Let's rebuild the model. So it tells me fund category came out reweighted with those taken out. Fund category and international, which we saw visually, came out really high. These ones are not aligned with it. The beta ratio, which we hadn't looked at, so if it's not there, it's most likely to be poor if it's these ones. Manager tenure, we hadn't looked at that before. Kind of here, if I can see 4 years, 3 years, and here's the bigger years. Looks like if the manager's been involved with the fund for a shorter period of time, it's more likely to have poor performance. Well, that's something that I did not see visually. So you could keep going through this, but it's giving me a better understanding and it's complementing what I saw visually. So now what we want to do is let's score the rest of the portfolio. I'll click Predict. Just wrote some scores in, a predicted and a score. Let's look at those. So I'm going to open up a new page. I'm playing the power user role. Open up here, Add New Page. I'm going to call it Model Outputs. And on this page, I want to add some charts. So let's add some new charts. I'm going to bring up a bar chart to show the BIND 1-0 score, a histogram to show the range scores, a data sheet to show the individual elements, and a counts chart to look at what I've got. So let's put the charts. This chart is only one table. Let's put it on the selection predicted. Click OK. I'm going to just count. So it's telling me the ones. It expected 100 funds based on that model to be in that top left quadrant. 60 already are, so it was 40 new. Now, this could be employees at risk. This could be credit claims that we're worried about. There's a whole lot of conditions where you're trying to, students who are at risk of not making it through the second year. All of those things, you've got a set of conditions that are likely to cause a problem. 60 already are, but there's 40 new ones. We're going to get to those in a minute. Just looking at the score. So here's so the score. If I click the ones, you can sort of see it took this range score from low to high and binned it. So that's the ones, and the zeros are over on the left. So you can sort of see what the algorithms did. Let's go back to my selection. Let's put up a count so we see how many we're looking at. And then over here, I'm just going to put a couple of key measures, maybe fund name, manager tenure, one of the measures, and fund category. And I can rearrange my page splits here. But what we'd now like to do is get rid of the selected ones that are already there. So I'm going to go up here, exclude them, select the remainder. So now I have the 40 funds here. Here they are by category and some. I can sort of see if I sort them this way, there's a bunch of them that have low management tenure. There's a set of these conditions over here that together cause the model to rate them as high risk to be there. Go back to my first page. Let's close off some of this. I now have a view as to where they are. There's a cluster right under the zone, but there's some over here that are surprising. Like there's a fund here that's done really well, but it has the characteristics of the one that didn't. I might want to explain or explore some of these outlier groups here. Here's my list of the 40. So I'm done with my effort. I can right-click, export the list out. And I've got the high-scored ones out of Advisor into Excel. And I can do what I want with them. This could be a group of customers I want to send something to. It might be a set of employees I want to get into some additional training. But it's a set of entities that have conditions similar to the ones that had a problem that haven't yet had the problem. So and we also, we wanted to see the flight recorder. So let's get out of this, go back to the project, and let's open something. So now I've wondered what I've done with my selections here. I'm going to go to View, the flight recorder. So there's a panel on the left that's been talking about everything I did. So I did all these. I added a view. I selected in the bar chart. At one point, I selected this bar, the 1, and it shows me what I did. And then I went down here and I selected the other bar. I want to show them back and forth, and then I did, and then I excluded. So this is in the visual discovery and the model building. This is the cookie crumbs trail of everything I've done. So I know what I've done. I can go back to any state, and I can save it as a bookmark. Like if I wanted to go back here, I can create a bookmark, and this is the model output. I can save this bookmark for later use. I can share it with other people on my team, and it will save the selection state and take me back there. So what we just saw, let's come back and summarize back into the storyline. Most human minds can cross-correlate maybe 5, 10, or 15 factors. Modeling could easily cross-correlate hundreds of factors. The visualization is critical to hypothesis setting. By visually exploring the data, we had some ideas on what some of the key factors were. We could develop some explanatory fields. You'll see that in the next example. And you can examine the outputs after you've got the modeling. And it's all integrated together. So if you want to see where the high-risk outputs are, you can go back to the first page with the scatter plot, and there they are. You can export them and work with it all in one application without having to go back to databases and worry about SQL commands or preparing data. And we would argue this leads to faster and better decision-making. So again, we selected a target, visually explored it, selected a list of explanatory fields. The next example has more complex explanatory fields. We built a model. We saw we got some fields that were duplicative or coincidental with the selection on return. We took them out. We reran it, and generally you do this a few times. This is where the human mind and trying to really hone in on causality matters. Then we got lists from the model outputs. We had an understanding, but we also could predict and score the base population and get scored lists for further action, sort of the steps we typically go through. We'd argue this is best done with your team, which is why these new tools that combine visualization with analytics are key, because this is not a black box. It's a process, and generally the internal team knows the data in the context. And by making it so the person doing it doesn't need a statistics degree, they just need to know the data and the context, we would argue you get better results faster. And this is sort of a replacement for farming this out. Let's do it in-house and empower people to do it. So the next example is the consumer packaged goods sales. So this is a disguised data from a company that sells pretty much non-cyclical food products through the retail food chains in the U.S. and in Europe. So the question is, what factors drive sales? How do peaks in incremental sales relate to social media spikes? Because there's more and more of that going on for all brands, by each brand. How does it vary by media provider, by type of post? And can we use this data to forecast incremental forward sales? Which factors have the biggest impact? So in this example, first we did a visualization. This is literally, the blue line is sales over time from back a few years ago. This is the data from January 2009 up through June of 2011. And so this is revenue, top line. The next line is the actual incremental unit sales. And then we have the green line are inbound calls to the call center, which was thought to be one of the factors. The red line is something called, it's a promotional index. It's a total points spent on promotion, so it moved. And then the orange line is posts, which is Twitter, Facebook, all the social media posts. So you quickly see that that wasn't actually tracked until halfway or two-thirds the way through the period, then it came up and moved. So one way to try to untangle this is visually look at, when promotions go up, like here's a point, do sales go up? Do they lag? At the same time, they come down? Do they come down? And you can sort of see there seem to be peaks between the red line and the blue line. It went up here, that went up. But it's kind of hard to do this. So then you might say, let's drill it down to the week level, because maybe all of those things, we were looking here at the month level. This is totals by month. But we know these things happen faster than that. So here's the data at a week level. As the same data, you can try to look at the red line and the green line and the orange line and compare them to the sales spikes. And there's clearly some relationship, but it's hard. But what we can start doing here is, one of the issues is, do these lag and by how much? Like, do we want to, when we build our model, look at posts and sales and promotional points and calls in the same week as the sales, or the week before, or 2 weeks before? We would argue experiment and use the InMemory model to create several versions of this, and then let the model figure out whether it's the current week drives the sales, the week before, the 2 weeks back. It's fairly easy to set these things up, because visually exploring it, it's hard. I mean, this one looks like the peak here is identical with the peak there. Here's one over here that looks like, some of these look like it's a little bit before. Like this one, it peaked here, then that went up. So it's really hard to untangle this visually. So this is an area where modeling really helps. So the model runs against a table. In this case, the table was product sales from Nielsen. The target was the base dollar by brand by week. So we aggregated transactions into a brand week roll-up. And then the explanatory fields that were in the product sales table were the week. Obviously, there's cyclicality, so what week of the year matters. There were distribution discount points, so this sells out through distributors and retail channels. So one of the things along with the sales was, what were the discount levels for that particular brand for that week? And then there's promotion points. What was the total promotional activity? Obviously, these things influence sales. In this model, we used a T-1. So we took the distribution and promotion points from the week before to look at sales in the current week. And then there's other tables. So this is the main table, but then there's a blog posts table, which is what we had was the numbers of Twitter posts, Facebook posts, blog posts, WordPress forums, YouTube, and generic blogs, and I think a couple of others. By product by date, we rolled that up on brand by week. So we had brand X week to 23 Twitter posts, 15 Facebook posts for a several-year period. That was run through a sentiment engine because we wanted to know were these posts positive, neutral, negative. Then we had numbers of positive, numbers of neutral, numbers of negative posts by week by brand. We copied those back in the InMemory pool without touching the database to the product sales table. Then there was another table that was coming in from the customer service group about inquiries and suggestions in mainstream media. This was rolled up by brand by week, and the last source was inbound calls to the call center. So we had numbers of total calls, numbers of complaints, and numbers of praise. So as you're looking at forecasting a time series, I think one of the messages here is there's a lot of data that's there. And the trick is to get it into a form, into the one table where it can easily be modeled. Traditionally, the higher-end analytics tools have required a lot of database prep to get this in this form, where you have a row in here for each brand by week with all of these factors in one table. And these new in-memory front-end data discovery and analysis tools, this is pretty simple. You load these tables in from the various sources. This could be Oracle. Some of these came in from text files and Excel sheets. And then you remap them with ETL in the memory pool to get the data in the right form for the model. And again, here we lagged everything T1. Then we did a little more work visually. We looked at the keywords, because one question was, what are the keywords, and are there skews by keywords, by negative, by positive? So here's a heat map where the biggest word was add commercial. Then like, love was second. Looks like example was third, recipe, family, health, calorie. And we call the neutral ones as gold, the green positive, the red negative. We were looking visually to see, are there huge skews in this? And the answer was no. I mean, the balance between neutral, positive, negative, and mixed was pretty consistent across the keywords, and neutral dominates. And then we did a heat map of the regional markets colored by the promotional level. So here's, for example, Kroger, and it's got Kroger in the south, Kroger in wherever this is in Dallas. So you've got different locations and different retail channels these goods are going through. And then this is red is low promotion level and green is high promotion level. And we quickly saw that, yes, there's a relationship between promotion level and what the retail chain is and also where it is. For example, in this period, Pick and Rainbow and Cops were doing much more promotion than Food or Delhaize or Wegmans, and some of these were in between. So we expect in the modeling we need to see some relationship between what the retail chain is and the promotional level, and the model will kind of take out the double weighting, but we need to be aware that these things are correlated. So there's a set of things we examined visually as we went through the data. And then we ran a model. We had all those factors in there, and the model ran, and much like before, this is the promotional index, explained 35%. So irrespective of all the posts and tweets, discounting helps drive sales. Probably not a big surprise. Promotional level came in second down here. But then the third thing, so the thinking was all these social posts and Twitter and Facebook was going to drive, was actually complaints into the call center were more related to sales than these all the post stuff by quite a bit. This is 13.8%, and these things are like 5, and combined. So this started telling us that when people complain, they are more likely not to buy than if they're blogging on the product. Even if they're blogging on, most of the blogs were neutral, praise, pause. The negative blogs were down here at 1.4%. So it tells us that what we want to be most attentive to is inbound complaints to the call center and manage those very carefully. And our model actually did really well. The blue up here is the actual sales over time. The red is the forecasted sales from this model of all these factors, and you can see we hit it pretty well. And we got more accurate, and here's when the post data started coming in. Back here we didn't have the post, so it was without it. And then there's a lag in actually picking up the incremental sales. So we had the T-1 factors in advance, so you could actually see out here we were able to forecast out the next 3 weeks. With a 1-week lag, you can't forecast out a whole lot, obviously, but that, I think, is a lot of the periodicity of some of this. And so what we learned here, and if you actually look at here, the week of the year is the third factor. So cyclicality does play a role, but with these products, it's a fairly minor role. Actually, go back visually to the month. You can actually see the cyclicality a little bit. Back in this chart, you can sort of see sales fall in here in the summer, and then they fall again in the summer. But it's also a period when we cut promotions and other things. So the modeling figured out that the impact of the cyclicality was far less than the other things which we had control of. And so that's an example where we saw multiple influences. Creating the right explanatory factors is key. Getting the time lag right. Getting them grouped properly. Examining them visually and understanding some of the overlap between the retail chains and the promotional indices. Experimenting. We really like experimenting, and if in doubt, create more factors. The modeling tools will not use them if they don't matter. But getting that and just thinking it through is really important. This is a model we did in literally a few hours. I mean, in these new discovery and analysis tools, you're not doing the prep in the database. You're doing it offline in an in-memory engine where it's easy to do this stuff, to change it, to, hey, I never thought of this until I saw it on the heat map. Let's throw another factor in, rerun the model. And we learned that seasonality is not the major driver, that the key influences can in fact be managed and balanced. So to summary, we just covered quite a bit about interactive visualization, went through an example, learned some things, and we found out more by doing the modeling, and then we brought them together and saw how we got some really good insight about first a segment performance problem and secondly a time series problem. Came to some insights, and there's things in both of those, especially the last one, where the team could take action and understand what they really needed to manage to keep incremental sales up. So that's this has been recorded. We'll have it posted in a week or so, and we're open for some questions now. So the two ways to get questions is to, on the bottom of the webinar panel on the right, there's a chat and there's a question place. You can also raise your hand if you're bold enough, and we'll unmute you and you can talk live, and we'll answer your question that way. So I'm just setting up the panel over here. So what do we have? Well, there's a question of how challenging is it for business analysts to use something like this? So what we showed here is a capability that fits sort of in between some of the, if you have a team with trained statisticians who use SAS and SPSS and some of the higher end tools, there's a ton of flexibility and capability there that is not available in this kind of a more mainstream discovery and analysis tool. But there's a handful of people that have those skills. So what we have found is people who are inquisitive, can understand causal relationships. This is fine for, it's perfect for. And it's more important to have those skills than the statistics skills, because the key to this is seeing things and having the mind to explore them and go down, they might be tangents, but go down paths and cut them off if they don't make causal sense, but keep going if they do. And it's those sets of skills. And there's a set of these tools that just made the mechanics easier and easier. So you don't need the technical database skills. You don't need to do a whole lot of math and stats to use them. You just need to have a sharp, inquisitive mind. The question, what kinds of problems are these used on? I'd say that runs a gamut. We certainly do a lot of work with these on sales and marketing problems. We do a lot of work in higher education, and so we would, trying to find the characteristics of alums who are likely to give large amounts of money to a certain cause, neuroscience or financial aid or just in general. You can create these scoring indices and create highly prioritized lists. If it's a marketing thing where you're trying to figure out the characteristics of people who are likely to respond to a promotion, you can look at past response rates and find characteristics in purchasing patterns and click-throughs and things, and that all comes together. We've done risk analysis with medical claims, trying to find potential loss situations. We've done work on human relations where you're trying to find where are you at risk with employees leaving based on training curriculum and performance and all of that. There's a whole set of things here where there's stories in the data, and having something that helps you untangle across the 15, 20, 30, in some cases higher ed fundraising is one with a lot of fields, 400 or 500 factors what really matters, is really useful. And our work here spans industry and problem type, but it's those where there's a bunch of dimensions or measures, and people are trying to get scored ranked lists and understand what a certain behavior pattern has been like and why who else might fit that same pattern. Do you think this could replace Excel? That's a pretty bold question. Well, Excel has like 100 and something million users, so I wish it would. I think Excel solves a sort of a simpler level problem. I mean, if you have a data set that flattens easily into a table, Excel's a really powerful tool. What we're showing here, especially the last one, is the data is coming from multiple sources, and you've either got to, that time series one, have somebody do a lot of database prep work and flatten it, or it's not going to go into Excel, and so you've got different ways of doing that. This is a really easy, valuable tool for something like that. What programming languages built the tool? These are all C++, C# tools, and ours run in a .NET application, so it runs on Windows PCs. What does your tool have out-of-the-box models, or does the analyst build their own specific to the use case industry? Our modeling tool is a multivariate regression, so it's you build models with it. We do, especially in higher education where we've done a lot of work, we have specific models for scoring attachment or engagement for wealth, philanthropic interest, and so forth. So we have ways of combining a series of factors. We there would use modeling to create weighting factors because every institution has different weights, but we tend to know what the fields are that need to be used in a situation like that. So you'd use the model, re-weight it to the specific institution, then put that into play as we load data. Then it's not doing modeling every day. It's just calculating these metrics that we then put in very user-friendly form. I guess that's another point. Another question here is, you don't want to show a 0.06 correlation coefficient to an end user or a 0.336 attachment score. We like to group those, so after you've done the modeling and you've created range scores, we like to bucket them and call them user-friendly things. Like if it's attachment, maybe create 5 groups. The most attached you might call owners. The next attached you might call highly engaged, and then the middle group moderately engaged, then maybe lightly engaged, and then the far left would call detached. And business people, especially business end users, are much more likely to relate to something like that that's in human-friendly terms than they are to the 0.063 model score. So kind of what I showed here was how to build the model, but I would strongly recommend as you put this into play, especially if you push it out to management and non-analytical type end users, think about a lot, creating groupings out of it and then putting handles and names on it that are user-friendly and quite useful. How difficult is it to identify the attributes that contribute to the predictive performance? In your example, you had social, chatter, promotions, call center calls. So the model literally just rips through whatever in the data table. What we like to do before you even touch the software is spend some time with 2 or 3 people who are familiar with the situation on a flip chart or a whiteboard and kind of discuss, what your hypotheses are that would influence the target. Like in that case, we're looking at sales of food branded products through channels. There's a set of things that obviously have an influence and would help you understand what's going on, and we kind of lay those out. Then it's, okay, where are these? How do we get them? And there clearly could be more. I mean, there could be click-throughs and newsletters that we didn't have, and there could be a bunch of other inputs. But that's like what we like to do is hypothesize and then see if the data exists. I know in our higher ed situation, one of the things that matters a lot is event attendance is a very good predictor of engagement, which is a very good predictor of giving. And oftentimes that is not being captured. Well, knowing that it's a key influencing factor that needs to get captured, and since something like that probably matters most going back the last year or 2 or 3, and pretty quickly you've got a good base of data to work from. So the other thing is just look at the data, muck around in it, explore it visually, and see if you see patterns. I mean, those line charts showed patterns, the heat map showed patterns, the parabox we saw in the mutual fund shows patterns, and then kind of map through and hypothesize whether it feels like it's causal, and let the model help you understand it better. How well does this tool integrate to enterprise systems? Yeah, the data sources here, especially in the consumer brands example, came from a set of, the call center data came from an Oracle database where the call center stuff was tracked. The Nielsen sales data was in a SQL Server database where data was being brought in from Nielsen and merged with internal sales data to create that. A lot of those posts and sentiment were coming in text files or Excel sheets. So Typically, when we're doing this work, we're pulling into the InMemory repository data from a number of sources, and as long as there's some way to key them back and forth, it's fine. In the social media example, the keying was the brand name and the week of the year. So it'd be like, brand A, 2013 week 10. And in each of those tables had, so the posts were, a brand was in it, could be parsed out, and then we obviously had the date. So we were able to key everything back that way and then integrate it in the InMemory repository. It's pretty easy to do. Can I connect my relational database sources to this app, or do I need to download data into the tool? These in-memory apps will load directly from most common databases. Like we have readers for SQL Server, Oracle, Teradata, Pervasive, MySQL, and a bunch of others, and we can also load text files and stuff. So the analyst doing the work, as long as they have network access and permissions to get to the databases, it's a pretty simple straight load. So if there's marts, data warehouses, we can load from that. Often, some of this you need to go back behind that to get source tables, because often the marts are set for reporting, but they may not have the depth of the data you need to create the metrics and the groupings for the modeling. So just be aware that if there's a data mart, that can help ease the loading issue, but you often do need to go back and get other tables, and all of these in-memory front-end tools are good at doing that. The models, what do you think is the upper limit for model size and complexity? Yeah, good question. So these models are running through on, I don't know what the data size was, tens of thousands of things, so they execute really quickly. We have run models on, a couple million entities, and these algorithms, they're fast algorithms that we have in here. But if you try to build a model on 1.5 million with 150 fields, that's going to take 15 minutes or so to execute, and it goes up. I'm not sure linearly or exponentially. It doesn't go up exponentially. It goes up from that. So you just have to be aware. The visual discovery part, we get sub-second response on 100 million rows, so you can plop a lot of stuff in, because that's just executing in RAM across a bunch. But the modeling, you actually have to rip through all of the rows and across multiple fields and it's binning, and it's actually, the algorithms create 25 to 30 models and picks the best one, so that just takes a little bit. So yeah, if you've got 1 million customers or claims, that's a 15-minute run, maybe 10, 20, depending on what the fields are. If you're 20 million, you probably go grab lunch and come back. I mean, it'll complete. There's no theoretical limit, but practically, that's what these are taking. And there's obviously, if you've got like a massive data set, you can aggregate it up and get a feel, then break down on like a sampled subset of it. So there's other ways of tackling much larger data sets. But this tool, as is meant to operate in those ranges. Is the tool SaaS or on-premise? So the modeling tool, the way we've structured our apps is the modeling tool and the authoring tools are Windows client-based. They run on PCs. And the deployment, like I could push these out over the web so people would have all of the interaction but not the authoring and modeling, runs on a Windows server which can be hosted anywhere. We have a SaaS offering for that. So often we'll have a group of 5 power users doing what I was just doing. They might create the scoring indices and rename them into owner, highly attached, those things, and that might go out to a group of 100 from a SaaS model over the web, accessed by browsers or iPads or whatever they use. A lot of questions. Are the patterns automatically detected in some way or by manual adjusting? Well, the patterns, you go back to the modeling output. These patterns, and you saw before when I did the mutual funds, the bucketed bins are all automatically created. So, for example, complaints, the 13.8% is one of the fields. But then on the mutual funds demo, we saw that for each of the fields down below, it gave me the lift buckets. So the numbers of complaints, you're going to have a brand week where there is, I don't have this is a PowerPoint, so I can't drill into it, but it might be the week that's really bad is 5 to 10, and moderately bad is 4 to 5, and then 0 is the negative lift. So it actually does automatically create the lift buckets, which is what the modeling then uses. If you're in that higher group, you get a higher score. If you're in the middle group, you get a middle score, and it'll create statistically somewhere between 2 and maybe 15 buckets is sort of what it's trying to do, and that's all automated. You can export the buckets out. Off the bottom of this is a little control export the buckets, which sticks them in. It writes them back into the entity table, much like it just did with the scores a few minutes ago. Which type of prediction algorithm have we used for the models? Yeah, we have in here, it's a multivariate regression. It's a very close-fitting multivariate regression algorithm. There are a variety of other algorithm types. SAS or an SPSS would clearly allow you to do that, but that requires more sophistication to pick and fine-tune than the user group we're going after. And part of our proxy here is you're better off turning around a model in a couple of hours and getting it understandable than spending a whole lot of time and fine tweaking it to perfection, because the whole thing about statistics is it's never 100%. So I'd argue we're getting 70, 75, 80% of the value out of here, and these by tweaking models and all of that, you're going to get higher accuracy. But how much more is it? How much more is it? And is it worth the time delay? And is it even worth it if your team can't actually execute it? So yeah, there are other algorithms. There's neural nets, and there's all kinds of other algorithms, clustering algorithms. I would argue with something simple like this, you can get most of the value quickly, and that's better. But clearly, people that are skilled and can use other modeling algorithms, there's some great tools on the market out there. The data update in real time. So Advisor, we're a strategic and tactical decision-making tool. So we load data two ways: on demand. If I'm in the project, I could refresh data from its varying sources, and at that point in time, it's going to go load the SQL tables, the Oracle tables, the text files, the spreadsheets, all that, and reload everything. Generally, in production, we set up so we load on some trigger, usually daily, and most of our clients want to have a snapshot. So somebody does some work at 9 in the morning, they get some insights, they go to their boss at 11, they know that it's the same data and it's snapshotted from the day before. We can run with more frequent updates, we can run on demand, but what we're seeing is in the world we work in, so we're not a real-time operational, we're not running in production floors trying to turn on and off valves. We're trying to help people look at historic data and figure out, are there problems in this area of my production floor? So for those problems, you generally don't need real-time regular updates. You might want to go on demand in an update, and that's what we do. How do you sort out the data into different charts? Oh, well, we did a little bit of that in the mutual funds. Did I keep that open or did I shut it down? I shut it down. I can open it back up. So yeah, here's the project I was, so we author on the client. Let's open this back up, and we'll be here pretty quickly. So loads the data up, the flight recorder is open on the right, navigation pane on the left. So here's the project I was working with. The way we author, it's a couple of ways. Let's hide the navigation panes. There's something called the task view, which I had shut down. So if I want to add a new chart to this page, maybe I don't like the bar chart anymore, I want to stick a pie chart in. I click, add new chart. I get a panel, want to add a pie chart. I click OK. On the pie chart, there's only one table here. If there's multiple tables, I could apply it to any one of the tables. There's another tool when we load data up here. We then got a link and join tables, so we load data. We set color, pages. We create links between the tables so that they all operate together. But here I just got one table. I want to put the field on fund category, and I want to set the measure by let's make it be count. Click OK. So I want to maybe drag this over here and dump my pie chart. my bar chart. So now I've replaced the bar chart with a pie and change the label. So we try to make the authoring, actually keep a fun category, change the label. Very, very point and click, very easy. And these charts come up, they know each other because they're linked to the data. And so this pie chart is much like this. If I grab the international, that updates. I grab the growth, I grab the balanced, all of that. If I grab the top corner here, the pie chart's updating and showing the concentrations. So that's our authoring. Can one chart pull information from 2 or 3 different data sets? No, our charts attach to single tables, but they're linked to different data sets in the in-memory pool. So in interaction on any chart, and we call this a project where it's got multiple pages and each page has a set of charts. In interaction on any chart on any page updates, if it's set this way, which is the default, all of the charts on all of the pages, irrespective of which tables the charts are on. So there's a back end to this where you can picture there could be 50 tables from these different sources all keyed together. And if I click the international, it updates it here. If there was another table that was, I don't know, whatever it would be, posts to the internet, posts about the international fund, that whole table would update, and you'd see all of the posts about the international fund over whatever period it had it. So if you wanted charts on multiple tables, you could tile them side by side on a page, and then you'd see the interaction between them, and you see these different aspects of that same data. When the data set is porous due to inconsistent data capture and reluctance to change, how effective can this tool be to leverage a change of culture? What advice can you give considering how to begin? Yeah, so that's a good question. There's sort of multiple sides. So if you have incomplete data, it's spacious, there's things that should be there that aren't. First, the modeling tool has a cleansing algorithm that's pretty good at that, and if it's looking at how much the data is empty versus there, if it needs to be transformed from a linear to an X, there's a bunch of transformation that happened behind the scenes that you don't have to worry about. And so the modeling is okay with spacious data, although I would recommend the user to also take the field out if they know it's spacious. This data doesn't have null. Our charts will all show that really well. I mean, I took the bar chart out, but the bar chart, can show null values, and you'll see it. We also have the ability in the tables, if one table is, like if you have a customer table or an alumni table with 1 million people, and then you have an event attendance table, which some of those people are and some are not. The chart on the attendance table can look back at the people table and put a bar in for everybody that's not been to an event. So spacious or data that doesn't align, we can do cross looks between tables and find things. There's a variety of ways of showing null data. There's a variety of ways of showing duplicate keys. So one of the unintended benefits of building these projects is exactly this point. It spots anomalies in the data, holes in the data, null values in the data. We had one client where they were looking up some town like Laguna, California, but it was spelled 4 different ways. So when I did the query in the database, they thought they got everybody in the town, but they didn't. And when they put it in, I need my bar chart back, but when they put in the bar chart, they all of a sudden saw side by side there were all these things they never saw before. That's actually a really good example of visual discovery, dirty data that should be cleaned up. We'll get the rest of these. I know we're running into overtime here. We'll stay on for a few more minutes, and we'll get the rest of the questions afterwards. Will we get an email to let us know when the webinar will be posted? Yes. We'll have this posted sometime next week, and we'll push a message out probably right after Labor Day and let you know where it is. Yeah, how do you deploy the model to the real world, for example, a website? So if I can answer that pretty quick. So I actually took my model out, but here's my project. I could rebuild my model page, but in the interest of time, I'm not going to do that. But if I want to push this page out to the website, I go down here, Share Results, Publish Dashboard. I'm going to put it to my local host here just this time. I'm going to call it Test so I don't write right over something else. I just go through this. I can allow data to be exported or not. Click. It's going to find the web server. Click Demo. So now this thing is up on a server with a web access, and if I click on the link, it's going to open in a browser. If this is a web server, I could push this out to my team, whoever it is, with my project available, and it's what I just updated. So could have had, when I've had the modeling scores, if I had pushed this out, those modeling scores would have gone out to the community just like this, and then it opens on the browser, completely interactive, the way I set the thing. That's what we're doing here is allowing you to create these insights and then push them out to a group of people quickly. Does the tool run case series or clustering? Yeah, that's sort of back to the how many algorithms do we have, and the answer is it does not. And if you want other more complex algorithms, there's SPSS, SAS. There's a bunch of tools that do that really well. And our positioning is to come under them. They're great. We actually have clients that use us together with them. They can sort of more quickly muck around and explore in what we're doing, and then if they want to run really serious models and get the higher degree of accuracy, they can run them in SPSS or SAS. So we have a number of clients. We could actually give, if you're interested, come back to us so we can give you some references of people who use a lighter footprint discovery tool like this, along with the more complex, higher-end tools. So is the ASPX page and can be integrated with existing page? Well, our pages are links, and yes, they can be embedded in a page. When I went through the questions, can our browser app be embedded in a web page? The answer is yes. When I published this, it asked me right down here, publishing using a server template. This would be a web page that we would then frame into. So our URL to launch us can be posted in anything, an email, a portal, a browser, a web page. When you execute it, it opens our app, which then can frame in a web page of any size. And if security is enabled, it'll push for security and log on, and then we'll open in the page. So yeah, we often are framed in other web pages. We often know we're not, and this is an example of where was the browser version. We're taking the whole browser, and we've got navigation and description on the left, and then we're over here, and this you can slide out of the way if you want to give the charts more room. This is sort of typically how we deploy, but yes, we can frame and launch into web pages. Does it integrate with SharePoint? We launch from SharePoint, but we're not integrated with SharePoint. Often SharePoint is a portal where there'll be icons that'll launch us, but we are a separate app that run in our own browser. And what's the underlying in-memory database? So we're a spin-off from Lucent Bell Labs, our technology, and it's our own proprietary. It's a heavily compressed binary store that's really efficient on the use of RAM. We could fit, as an example would be 60 Oracle tables. I know one example, 20 million rows, 400 fields. It fits in about 4.5 gigs of RAM and will run on a laptop. We have another example, 100 million rows, 60 Oracle tables, 300 fields, fits in about 7 gigs of RAM, tight on a laptop, runs fine on a server. And so to do that, we're obviously pretty efficient in how we store strings, how we index things, how we cross-link the tables, all of that. So one of the things we've done really well at as a company. When the data is loaded, where is it stored? So there's two questions. We load from a database into what we call a project. These things sitting on my desktop are projects. The Mutuals Fund is a little tiny one. If I right-click on it, it is a project with 143 kilobytes. These are bigger projects. Here's one with a bunch of Oracle tables in it. It's a 40 meg project file. It's like probably 4 or 5 million rows. So we pull the data from the source systems, Oracle, SQL Server, Teradata, whatever it is. We compress and embed it in this project file, and this file server goes somewhere, usually on a local file server, and then if it's executed either by the web version or the client version, opens in RAM either on the web version or the client version, and it serves up. You've seen examples of that. This can also be swept. We have a hosted offering where it would be swept up as one file with the 20 tables in it, in this case, to our hosted provider, where it then would be accessed from there. So several answers to that question. Normally, this file would run inside the firewall, be executed inside the firewall. In the hosted environment, we're moving this one file, usually once a day, through a secure FTP transfer to our hosted environment. It's obviously much more efficient way than moving the 20 tables that it loaded from. No, we're moving this one compressed file with all 20 tables in it. Can we create dashboards from other dashboards? Something like link from one report to another. You can, in that, for example, what happened to it? I need the navigation pane. We have these things on the left called navigation panes. So these can contain text links, and the links in here could be to videos. The links could be to other projects or dashboards, and if you execute them, they'll open a browser with the other project in it. So we have had people who do that, where we're in the mutual funds and you're on this page, and then maybe there's something that says, if you really want to see this, click here, and it opens some other view of this that's totally different. Can we create do you set any decision-making rules? Decision-making rules, well, we set workflow and we set metrics, so we can embed decision-making rules into the metrics and measures we show in the charts, and we can put goal lines and different things on, and we could put text over here. But it's all about exploring and seeing outliers and finding things. We can do things with colors as well, so that if something clears some threshold, it shows up somewhere, turn red or something. So yeah, there's a variety of ways of creating metrics and triggers so that they jump and somebody can do something with it. And Rosie, if we're running into overtime, I'll take one more question. We still have a good group on. Can we create 3D diagrams? So Advisor. Good question. Advisor has 15 chart types. Easiest way to see them is here. Go back to my task view. This thing. Close this. Add. Come back. Add new charts. So there's a palette of charts that this comes with. The bar chart can be horizontal, vertical spline plots. The constellation is a nodes and links view that can be 3D because in some cases there's a reason. So it's showing relationships. The line chart is the 3D is a multiscape, which has an XYZ plot axis. We plot maps. A map can also be a globe, so that can be a 3D. So some of these, I guess this one, and the constellation all can have a 3D view. Normally those aren't used that way because we find most business people struggle with a 3D view, and we've actually backed off some of that. I'd say that many of our charts can have far more than 3 dimensions. Like a scatter plot uses the x-axis as one, the y-axis is the second dimension, color is a third dimension, shape can be a fourth dimension, and size can be a fifth dimension. So I'd actually argue a scatter plot's a 5D plot, but it's plotted on a 2D plane, versus the multiscape is an XYZ plane, but it actually shows less information in some context. So there's purposes for this, but I'd say in general we've backed off of that, and I'd urge caution on some of the flashier 3D charts because we're finding most business people have trouble engaging with them. How often does your company release new versions? We're pretty much on like a 7-month release cycle. We had a release, 6.0 came out in May. We have a 6.1 release that's due out the very beginning of October. And then we're looking at a 6.2 probably next April. So we're trying to keep a fairly quick pace, and the last couple of releases have done a lot with that flight recorder concept. We've done a bunch on look and feel. We've now added different aspects to our charts. So I don't have a bar up here, but you can label, put measures on bars. So there's a lot we've done in each release with both the charts, the in-memory capability, and we've updated our algorithms as well in the analytics. So yeah, we're continuing to move aggressively on multiple fronts. I think a year ago, it was more than a year ago, we came out with iPad and all of that stuff. So I think I appreciate it. We have a good group on. We will, this has been recorded. We'll have it out in a week or so to all of you. And any unanswered questions we'll get offline. And we're here if you want to continue the dialogue. So thank you very much for your great attention here, and appreciate your time, and good luck with visualization and predictive modeling. Hope this was helpful. Take care.